ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన ఎన్ఎస్ఆర్ ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ ఎన్ఎస్ఆర్ ఇంపల్స్.
Hi everyone. So today we will discuss more number of problems. We already discussed a lot, but there are some lot of things to be discussed. So we'll see. The first one, a circuit was given, a simple circuit where the capacitance is C and one more capacitance is 2C given to the cell of EMF 10 volts and it is grounded, and here also it is grounded. Now they are asking the question that charge stored in the capacitor. What is the charge stored in capacitor? In capacitor C. So here you see there is a single branch, so that you can say that all the capacitors are connected in series. All the capacitors connected in series. And I will tell you one more thing. See, as it is 0 volts because grounded 0, and we are going from negative to plus. Negative to plus means gain. So how much we are gaining in the current electricity chapter in class 10th? You may come across the drops and gains of the voltages, right? So here initially it is 0, and when we are going like this, we are going from minus to plus, means we are gaining the voltage. So that how much is gaining? 10, means can I say this end is 10 volts, this end is 10 volts, and here it is grounded, means this is 0 volts, means this point also 0 volts. Now can I simply say that across these capacitors what is the drops? 10 and 0. What is the potential difference? 10 volts. Now as these two are in series, as capacitors in series, we will replace this with C equivalent. What is the series formula? C series is equal to, I told you, multiply product by sum. C1 C2 by C1 plus C2. C1 is C, C2 is 2C by C plus 2C. It will be 2C square by 3C, cancels with 1C. So 2 upon 3 into C. This is what the capacitance we got. So that the circuit now I will draw with a simple equivalent capacitance. With this is grounded and this is given to the battery and grounded. Now I told you already, so for the capacitor end points are, this is 10 volts and this is 0 volts. Now you know the terminal voltage between of the capacitor. So from that one you know charge will be drawn. So what is the charge formula? Q is equal to CV. Now Q is equal to, what is C equivalent? Is 2 upon C 2 by 3 into, what is the voltage we are giving? 10 and 0, end points 10. So what is the total charge will be drawn? So 20 by 3 into C. This is the charge taken by the equivalent capacitor, and you know that as this is in series, the same charge Q flows through the both of them. The same charge Q flows through the both of them. Now what is the answer? What is the charge stored? 20 by 3 times C. Understand? Next we will discuss one more thing. Next question. So here the problem is, the circuit is given like this. There are some capacitors. This is 2 microfarad, this is also 2 microfarad, and here also 2 microfarad. And now this is 5, 3, 4 and this is 5, this is 3 and last one is 4 microfarad, and they are given the connections like this. And to the 4, and it has been given to the battery. So the switch is closed, okay na? So this is of 100 volts. Now the question is, so find charge stored in 5 microfarad capacitor. Find charge stored in 5 microfarad capacitance. So think about the question. See, here the simple funda is, when something is connected, some wire is connected. So wire is connected means the potential will simply carry. So wire, it is a conductor na, means it will bring the same potential. If this is 20 volts, this brings the same 20 volts here. So I can say that as it is 100, I can say it is 100 volts and it is 0. Can I take like that? Because this 100 volts is a difference. So 100 and 0, 100 minus 0, 0, 100. Now this is 100 means this will be 100, this will be 100. So what is this one? 100 volts. And this is 0 means this will be 0. Right. Now, see, this 100 volts will be carried because as a conductor, so this is simple wire, it takes the same potential. So can I say at this also 100 volts? Okay. Now, if you say some potential is dropped, so let me take this is some V1, something V1 might be like V1 might be some 50 volts or 40 volts something. So at this common node, V1 is the voltage, so that here also V1 and here also V1, right. Okay, then so simply you can say that about this branch, and this is 5, this is 3, as they are in series, you can do the C equivalent, 5 into 3 by 5 plus 3, 15, okay. Now can I say about this branch endpoints are same, V1 and V1. Now is there any potential difference? No. So about the loop identified there, so which is 5 and 3, 5 microfarad and 3 microfarad, the voltages are same, V1 and V1. Now what is the potential difference? Delta V is nothing but V1 minus V1, 0. Now there is no potential. When potential difference is there, then only charge moves. When potential difference, high potential and low potential is there, then only charge flows. There is no potential difference. Now what is the charge passing through this branch? So charge passing through this one will be 0. That is why what is the answer? Find charge stored in 5 micro. Is there any charge storing? No. So charge flowing through the battery, 5 microfarad is 0. Here what we have observed? Only the points, end points concept. Here the conductor will carry the potential, so that this is 100 means this is 100, and here at some node we have assumed some V1 voltage. So this V1 voltage will be carried here also, and this V1 will carried here also, and to this branch endpoints are same, there is no potential difference, so that charge is 0. Right. Now discuss one more, the same type of problem. Here it is a part of a branch, it is a part of a branch where this one is 2 volts and there is a capacitance, this is plus minus given, and it is a Q1 charge, and here it is a battery of voltage 2 volts, and this is some capacitor of charge Q3, this is given plus minus, and it is 3 volts. and here one more capacitance is given as Q2, this is minus, this is plus, this charge is Q2 and this potential is, let me take 2 volts. Okay, now they are asking, so this all the like capacitances are 2 microfarad. So what is this capacitance value? 2 microfarad. This capacitor also 2 microfarad. This also 2 microfarad. So capacitors values they have given. Now the question is, find charges passing through all capacitors. The question is charges asking, means Q1 value how much, Q2 value how much and Q3. So here see, it is a simple that part of a entire circuit given, okay, and see here this 3 volts and this is 2, but we don't know what is the node voltage. Let it be X. Let X be the voltage of or potential of the node. Potential of node. This node name is, I am taking as A. Node A. So what I am going to, so here at node A, okay, here I will tell you one method. So this is purely based on assumption, okay na. Even though if you go by using the Kirchhoff's laws, then you can get the answer. Now my logic, you can say this is my procedure, okay, right. So here I am assuming X as the potential. Can you identify the potentials across each capacitor? See, for this capacitor 2 volts is the one end point, X is one end point. For this capacitor 2 volts as one end point, X as one end point. For this is a battery. So that, see, can I say that when I am going like this, this is X, I am going with the battery and this is a capacitor and this is 3 volts. See, I am going from plus to minus. If this is X volts, what is this battery voltage is 2 volts, means this point must be, see, this is X and I am going plus to minus, means drop, means so it is dropped from X, 2 volts is dropped, so that this voltage will be X minus 2. So that at this capacitor the end points are, one is 3 volts, another is X minus 2 volts. Okay, so we identified all the potentials across each capacitor, right. Now what I need to do, at a node I am just assuming this is a node, I am assuming some charge, all the charges are coming towards, so as it is Q1, as it is Q2 and Q3. So all the charges coming, so that we know from Kirchhoff law, charges entering is equal to charges leaving, so that there is no charge leave, it is my assumption. So that charges entering is equal to charges leave. So that, so here charges entering will be Q1 plus Q2 plus Q3, so no charge is leaving. Now Q1, Q2, Q3, I just assume like that. It may not be taken place, but I assume that all the charges are coming. Now you know that charge formula. What is charge formula? Q equal to CV. Now what is Q1? C1 into the drops across C1. So C1 into what is the drops across capacitor? This is 2 volts, this is X volts. So 2 is more coming na, it is coming means this end is more. So 2 minus X plus Q2, this is Q2, charge is coming, so 2 is more than X. So capacitance is C2 into 2 minus X plus this is also coming. So what is the charge? Q3 is equal to CV. C is C3. What is the potential across this capacitor? This is 3, this is X minus 2. So coming means 3 is more. 3 minus X minus 2 is equal to 0. Is equal to 0. And you keep the values of C, C2, C3. They said that C1 is 2 micro, C2 is 2 micro, this is 2 micro. So take C out, all are same. So that 2 minus x plus 2 minus x plus 3 minus x minus minus plus 2 will be 0. So that this can be 0 or this can be 0. But C value, some value is there, it cannot be 0. So that this thing must be 0. Sir, see. 2 minus x, solve it, minus x, minus x, minus x, minus 3x, 2, 2, 7, 9. So, you can say that minus 3x plus 9 is equal to 0, then x is equal to how much? Is it okay? 2 plus 2, 4, 7, 9, minus x, minus x, minus x, okay. So, you can say that minus 3x is 9, so that 3x is equal to 9, then x is equal to 9 by 3, which is, we now found the node voltage. Now tell me, so when you know the node voltages, means across the capacitor potentials, it is very easy to find out the charges. Now I want charge Q1, which is C1 into the potential difference across the C1. Are see, C1, this is C1, and what are the potential drops? It is 2 volts, and we know the x is 3. So x is 3. So that C1 value 2 micro into what is the potential drop? 2 volts, and x we found as a 3, drop is 1. So that the drop is 1 volt. So you can say that magnitude of charge is nothing but 2 microcoulombs. 2 microcoulombs. Now coming to the Q2. Again Q2. For this Q2 endpoints are 2 and this is 3. So that C is 2 micro and again 1 volt difference, 2 volts, and this is 3 volts, the difference is 1 volt. So this can be 2 microcoulomb, this is magnitude. And what about Q3? Q3 is nothing but this is 2 micro, and what is the drop? See, this is 3 volts, this is 3 volts, and as I got x value how much? 3, 3 from this 2 drops, because 3 we are going for plus 2 minus means drop. What is this voltage? I told you x minus 2 means 3 minus 2, which is 1 volt. So this is 1 volt, this is 3 volts. What is the difference? 2 volts. So simply 2 volts. Now what is the answer? 4 microcoulombs. So that is how this 4 microcoulombs will come like this, and that will be divided into 2. One will like this, one will like this, because 3 to 2, 3 to, this is 2 microcoulombs, this is 2 microcoulombs. Understood? So this is how to do the, by applying nodal analysis. We'll, right. So we'll see one more problem based on the series and parallel combination, how to identify the potentials. Okay, now how to identify which are in series, which are in parallel. Right. There is a question. And it is B, so that it is a circle. Okay, na? See, there are 3 capacitors. Each capacitance value is C, and this is A, this is B. Now they are asking what is the equivalent capacitance between A and B. Sir, how to do this type of questions? See, first we need to know which are in series, which are in parallel. If the diagram is somewhat difficult to unable to identify these series and parallel in a first attempt, so what method we are following? See, I will connect a battery. So connect battery between A and B. Means here we are just connecting a battery like this. Okay, na? So here battery of voltage V means you know that this voltage is V, this voltage is 0. You know, while we are taking battery voltage of V, positive terminal is of voltage V and negative is 0. It means this point also V, means this point also V, this point also V, this point also V. So and this is 0 means this is 0, this is 0 volts, this is 0 volts, this also 0 volts. Now you are very easy here, you got a point that at every capacitor end points, see the end points. For this capacitor this is V, this is 0. For this capacitor this is V, this is 0. For this capacitor this is V, this is 0. Means every capacitor, every C has end points V and 0 volts. Means end points are same, means they are in parallel. So all the three are in parallel. You can simply say like this, all the three are like they are maintained at this is V, this is 0. So when they are like a parallel, what is the formula for parallel? Cp is nothing but C1 plus C2 plus C3, but all are equal, so that C plus C plus C, which is 3C. So this is what the equivalent capacitance. So here what is the method here we are following? We are identifying the end point potentials, end point potential by keeping the battery in between A and B, where they are asking the equivalent capacitance. Now we'll see one more problem, the same thing, the same type of question. Again circle, but here I am connecting a capacitance. So C, this is A. Now how many capacitors are there in the circuit? 4. So we need to replace the 4 by a single capacitance called as a C equivalent. Here also I will follow the same method. Here I will connect a battery of voltage V and this is 0. Now when this is voltage V, this will be V and this will be V, this point will be V, this point will be V, and whenever it is 0, this is 0, this is 0, and this one will be 0. Now see, and this one also 0 because no drop here. So for this capacitor, what are the end points? 0 and 0. So for this capacitor, end points, this is 0 volts, this is 0 volts. So there is no voltage or potential difference. So this will not work. This will not work. Now, so we will see remaining. So for each capacitor, this is V0, this is V0, this is V0. So again they are in parallel, they are in parallel. Now use the formula Cp is equal to 3 times C. You will get the same problem again. So here what I am doing here, identifying the end points, identifying the end points. We will see one more thing, right? The same type of question here with a little difference. Right, so here is 0, 0, I am just erasing. Now I am giving 2 more capacitors, one is here like this and one is here like this. Okay na? So C. Now how many capacitors we have? 5 here. 1, 2, 3, 4, 5. Out of the 5 you need to require only one single capacitance, right? Achha. Then we again connect the battery of voltage V and 0. So it is 0 means this also 0, this is 0, this is also 0, and whenever you say this is V, now here some drop is there, let me take some V dash. Okay na? Now identify the end points. For this capacitor V and 0, okay. For this capacitor V and 0. For this capacitor V and V dash. For this one V dash and 0. For this V dash and 0. I will draw a line such a way, this is a high voltage, this is a 0 voltage, in middle V dash some voltage like 20 volts, 10 volts, 0. I will draw a line. Now I will just keep the capacitors which has end points this VV dash and V dash and 0. Are see, this one has V dash and 0, means can I keep it here because end points are V dash and 0. For this end points are again V dash and 0, means I can keep. So 2 capacitors done, we have 3 left. Now come to this one, this is V and 0, means V and 0, V and 0, and this is done. Now coming to this one, V and V dash, means V in between V and V dash. So this one also done. Now coming to this one, V and 0, means finally V and 0. Now see how these two, their endpoints are V dash and 0, means they are in parallel. So in parallel you just solve. This is C, C. In parallel, what is the formula? C plus C, which is 2C. So this combination is 2C. And here it is, this is C, this is C, and this is 2C in a same single branch. So that this I can write as like this. This is C, and we got this one as 2C. This is V and 0. So these two are in series. So these two are in series means, you know the formula, in series C1 into C2, C1 into 2C by C1 plus C2. So that we will get as 2 by 3 upon C. So we got the entire thing as 2 by 3. Now see, this whole thing we got 2 by 3, and this is C, this is C. All these three branches have the endpoints V comma 0. So instead of this entire thing, I will write 2C by 3. Now this diagram can be written as, so this is one capacitor of value 2C by 3, and one more capacitance of C, and one more capacitance of C. So all of them are in parallel. Now what is the equivalent capacitance? Equivalent capacitance C equivalent is equal to sum of the all, means 2C by 3 plus C plus C. So it will be 2C by 3 plus, this is C plus C, 2C. So what is this one? 2C by 3 plus 2C will be 8C by 3. So this is what the equivalent circuit, equivalent capacitance for the given circuit. So here what we are doing, we are just identifying the endpoints of the capacitor, potentials of the capacitor across the capacitor, right? We will do one more. So I think we discussed about the infinite ladder circuit, right? Infinite ladder means the same loop is going to continue. Infinite ladder. Now we are going to see the same kind of problem with the different values. Okay. Here the circuit I am drawing. This is A, this is capacitance C, and this is one more capacitance C, and this is B. Now here the same structure with the different values I will keep. The same structure with the different values. Like this is going to infinity. So as it is CC, this will be 2C, 2C. This is 4C, 4C. This is 6C, this is 6C. Okay na? Sorry, this will be 8C. So if this infinite circuit is there, find equivalent capacitance. We already discussed when infinite ladder is going to take place. Now the method what I told you, identify some points A, B such a way that from that point again you will get the same problem, so that you can keep the whole thing as some equivalent capacitance. Now the entire this much diagram will become very short, then you can reduce the circuit and you can find out the equivalent capacitance. But here there is nothing to do like that, because here each capacitance values are changing. Now what I will do, see here from this circuit I am taking 2 common, so it means the circuit becomes, this is A, C and C. Now from this circuit I am taking 2 common, so that this circuit you can see how it becomes. This circuit becomes so when you take 2 common means only C left, C, C. Here 2 common means 2C, 2C. Here 2 common means 4C, 4C. Likewise, the circuit is going to repeat. See, we got the same question again. We got the same question again, so that you can keep here AB. Now this circuit capacitance we are assuming as C equivalent. That is what we want. In between the AB we want C equivalent. Now this circuit becomes very small, so that here A, here B, this is one capacitance, this is one more. Now here I can write, instead of this entire thing is C equivalent, it is multiplied by 2, so that I will keep a capacitor of 2 times C equivalent. But the circuit becomes very small now. You can reduce, you can just calculate. See, this capacitor endpoints are these two, this capacitor endpoints are these two. They are said to be in parallel. They are said to be in parallel. So that whenever it is parallel, what is the formula? Just adding only, so that it will become C plus 2 times C equivalent. Now the circuit I am changing. See, this is AB, A, B, and this is the first capacitor C, and in the place of this one I am keeping this. The place of this one I am keeping C plus 2 times C equivalent with to the battery, to the B. Now this 2 again in series in the same branch, that will be the answer of AB. So the answer of AB, what is answer of AB? C equivalent is nothing but combination of these two, means C and C, these two are in series. These two are in series means what is the formula? Product by sum. So C into this whole thing is C plus 2 times C equivalent by sum C plus 2 C equivalent. Okay na? Now, so here you can write C equivalent I am treating as a sum x. It is very easy to find out. Let C equivalent as some x. Now in mathematics you will get the quadratic equation. C, x is equal to C into C is C square, C into 2 into C into this equivalent I assume it as x by C plus C 2C plus 2 into x. Now cross multiply, so that you will get here as 2 times C into x plus x into x, 2x square is equal to C square plus 2cx. Now this 2x cancels. Now we got 2x square is equal to C square, then x square is equal to C square upon 2, then x is equal to C by root 2, which is nothing but x is nothing but C equivalent. So C equivalent of the circuit we got. So again for an infinite circuit ladder, we just converted. We should think for the logical point. So what is the logical point here? Again this, if you take 2 common, again you will get the same problem. That is why this whole the circuit I am just taken 2 common and wrote the same problem again. So this same problem is nothing but C equivalent. That is why I am writing 2 times C equivalent. So that circuit becomes very small. Okay na? Should you understand? So think for the logic. Okay. Now we will discuss one more question here. So these are based on the finding capacitors by the potential technique, identifying the end point potentials. Okay, we will see one more. So one more question here, based on the spherical capacitors. There is a spherical shell of inner radius capital R, and again there is one more shell is outer whose radius is 2r, whose radius is 2r. So these are called as concentric spherical shell. Okay na? Right. Now here they will keep some conducting material. Here they are keeping what? A conducting material. So you know that in a conductor electric field will be 0. The electric field lines will never passes through the conductor because electric field is 0. And you know that when you give the charge presents on the surface of the conductor material. Now the question is, they are keeping some point charge small q at a distance r. They kept a point charge small q at r, distance from the center where r is less than capital R. Means the charge is in the first inner shell, and you know this is like a cavity problem. This is like a cavity, there is empty space, some charge is kept. Due to that induction, some charges will be present, some charges will be distributed or created on the inner and outer shell, right? Now the question is, find electric potential at the center of the shell, at the center O. So they are just asking you what is the potential. Generally, if only one charge is there, what is the potential formula? V is equal to kq upon r, 1 by 4 pi epsilon naught charge by the distance. But here we should think about the induction, so that because of this charge q, because of this plus charge, there is a negative charge will induce. Negative charge, here what is the charge, negative charge will induce on the inner surface, and you know that this is the outer surface, so that here it is electric field 0 because it is a conductor, so that here negative charge, here nothing will be there, field will be 0, and on the outer surface plus charge, plus q. So we already studied that when any charge kept in the cavity, in the empty space, due to this opposite charge will be induced on the inner surface, same charge will be induced on the outer surface. Is it okay? Right. Now where we need to find the potential? At the center. So we need to find the potential at the center. So potential is because of the charges. How many charges are there here in the entire diagram? One is first one q, second one inside minus q, third one is plus q. 3 charges are there. Now I can say that potential due to charge q plus potential due to minus charge q induced on that, and potential due to plus charge induced on second shell. This is first. Okay na? Is it clear? Right. Now V at the center is equal to array due to small q. So you can say this distance they have given as some r. You know the formula, kq upon 1 by 4 pi epsilon naught q by, what is the distance from the center to this point? Small r, plus, what is the potential to minus q? See, this is the minus q surface. For this surface, the center is inside na? And we know already for a spherical shell, for inside point or on the surface, the potential is same, which is kq upon capital R. So that is why k is 1 by 4 pi epsilon naught. What is the charge? Negative charge. So that minus q upon radius is r. This is understood. And now the remaining is outer surface. Outer surface, what is the formula? 1 by 4 pi epsilon naught charge is q. What is the outer surface radius? 2r. So 2r. Now you are just taken out these common points. 1 by 4 pi epsilon naught q I am taking out. Now I left with 1 by r minus 1 by r plus 1 by 2r. This is the potential at the center. So in this question the main thing you need to understand is, because of some charge kept inside the shell, on the inner surface ulta negative charge will create, on the outer surface same charge will create. So due to that, potentials are nothing but potential due to the original charge, potential due to negative charge induced on the inner surface, potential due to outer charge. Okay, so this is how to do with potential concept. Okay now, right, so we will discuss one more question. Understand this one? Yes. Next, going for the next one, where this type of question already we did, finding the potentials and all, finding the potentials across the capacitors. The given question is, there is a battery of voltage 190 volts, and this was given to the capacitor C, and it is 3C. Okay now, and one more is there here. This capacitance is C and this capacitance is 3C, and it is connected like this. Now they have given some point A here and some point B here. Now what is the question? So question is nothing but find potential difference between A and B. Means at this point what is the potential, at this point what is the potential, the difference they are asking you, right? Now in this, how many batteries are there? Single battery. How many capacitors are there? 1 2 3 4 capacitors are there. They are asking potential difference. What is the potential difference formula? Q is equal to CV. So V is equal to Q upon C. So C value we know, but Q we don't know. So how to get Q value? So we need to search for the equivalent capacitance first. Tell me, how these two are in a single branch, so that C and 3C in a series. So in the second branch, C and 3C in series. Now what is effective? C effective, you know the formula. In series means product by sum. Product is C into 3C, by sum is C plus 3C. Now how much? So this is nothing but, so 3C square by 4C means 3 by 4 upon C. Now the circuit, see how the circuit becomes. The circuit becomes like this. So one is C, another is 3C. Now due to this 2, how much we got? 3 by 4 upon C. Now see how these two capacitors are. These two capacitors are looking parallel because their ends are same. Parallel. In parallel, what is the capacitance formula? C1 plus C2. Now C1 is 3C plus this is 3 by 4 upon C. Now how much? 4 3s are 12, 12 into 3 15, 12 plus 3 15, so 15 by 4 upon C. So this we got 15 by 4. Now the circuit will be like this. See, I am just converting the whole circuit into the simple one. So now this circuit becomes very small, where I can take this is 15 by 4 into C. Now what is the combination? Again you can say that these two are in series. Now series means what is the formula? Again formula will be C effective is equal to product upon sum. Product is C into 15 by 4 into C. Sum is C plus 15 by 4 into C. It will be 419. So the thing will be 15 upon 19 into C. So this is what the total capacitance we got. Now the circuit very simple. This is 190 volts and the C we got 15 by 19 C. Is it? Now, so we got the capacitance, we got the battery voltage. Now can you say some charge will start from the battery? So what is the charge will start from the battery? Q formula you know that CV. So what is C? 15 by 19 into C. What is the battery voltage? 190. So you can say 19 tens are. So it will be, charge will be 150 C. This much charge will start from the battery, means from this battery 150 C will start, means coming like this. Or when it coming like this, then it can split into two parts. Okay na? And you know that this is 3C and this we already solved because it is 3C by 4, so that these charges will divide. The coming charge 150C will be divided into 2 like this. Now you know, as they are in parallel, you know V is constant. Now you know that when V is constant, Q is directly proportional to C. More the capacitance, more the charge. And we require charge through this branch. This is I am taking as Q1, this I am taking as a Q2, where this is 3C by 4, okay, and this is it 3C by 4? Yes, this is 3C. Now, so we have the formula when charges will divide. We have a formula for division of the charges. Q1 is equal to C1 upon C1 plus C2 into the charge coming. So Q1 is equal to, what is C1? This one is 3C by 4 by 3C by 4 plus 3C into the charge, how much is coming? 150. So it will be 4 into 3, 12, 15. So it will be 3C upon 15. So it will be 1/5. Okay na? So 1/5 into 150. So how much? 30C. So this much charge is passing in this branch. Now we know what is the charge passing. Now how to, you know, this much charge 150, in that 150 30 coulombs, 30 C is passing. Now what is the potential drop? You know that AB drop, potential difference, AB is equal to, you know, Q is equal to CV. So V is equal to Q upon C. So charge upon C. Charge is how much? 30C by, so they both cancels. Now what is the voltage drop? 10 volt. So this is how to find out the potentials at a given points. See here, the simple thing here, I identified which are in series, which are in parallel, so that I got the effective capacitance, and the battery is given, so that some charge will start, and I find the charge started from the battery. That charge, how it divides, this is a simple fundamental thing. So how it divides, that division I have given some formulas, so that finally you can identify how much charge is passing through the required branch what you want in between AB. So you got the charge. So when you got the charge, potential formula is simply Q upon C. You will get the answer. Okay. So this is the question based on the potential drop method. Okay na. We'll see one more question. So this is what with capacitors, combination of capacitors and finding the potentials at every point. So how much potential is there on each capacitor? Okay, right. Now we'll see one more very interesting one where the circuit contains not a single battery, more than 1 batteries. Right, this circuit I am drawing, this is 4 microfarad and this is 20 volts, and here is given 10 volts, and this is 2 microfarad and this parallel once again 2 microfarad. Okay na? Now the question is what? The question is find charge stored in capacitor 4 microfarad. So they are asking what is the charge stored. So what does it means? Charge means we require Q. Our Q formula is what? Q is equal to CV. C value is what? In how much? What is the capacitance value? 4. Means what we require here? If you know what is the V value, then the question will be done. So if you are able to find out V, then C value already know, so that charge will come. So we should know what is the end points of what are the end points of that capacitors. Right, sir, how I will do? The simple thing, you know, these two how they are? These two are in parallel. So when they are in parallel, what is the formula? Simply sum only. 2 plus 2, 4. So 2 plus 2, 4. The circuit becomes, this is 4 micro and this is 20 volts, and we did this parallel connection. We got 4 microfarad and this is battery of 10 volts. This is 20 volts. Okay na? Now they both in the same circuit, right? So that is a single series circuit, you can say. Now see, this is plus, this is minus, this is minus, this is plus. If I take this one as a grounded, my assumption, this one as a grounded 0 volts. Now tell me, what is the, you are coming like this, you are coming from plus to minus, means this end must be, because drop na, from 0 how much is dropped? 10 dropped. So plus to minus, this is minus 10. Next, from this some drop will be there. Okay na? Again some x you can take. Now from this x, minus to plus means this end will be, minus to plus means gain, x plus 20, and from that x plus 20 something is dropped, so that you are getting 0. And as this is a series, charge is constant. As the circuit is series, charge is constant. Means what is the charge? Q is constant. What is the Q formula? CV. So Q is equal to, here I can say that at this capacitor, what is the charge formula? C is 4 micro and what is the potential drop? X plus 20 to 0 coming. So that drop is x plus 20. And the same charge will passes through this one. Here also, what is the charge? Q is equal to, C is 4 and what is the voltage drop? Minus 10 to x. So drop will be, you can say simply, if the charge is passing like this, okay na? So minus 10, this is minus x. So this will be minus 10 minus x. So we just equate these two. So that, so what is this first equation and second equation I can say? So charges are same, so this 4 cancels. So simply we will get x plus 20 is equal to minus 10 minus x, so that you will get 2x is equal to minus 30, then x is equal to minus 15 volts. So what is the x? Minus 15. So we got this potential. When you got the potential, what is they are asking? Q is equal to CV, charge passing through this one. Q is equal to, C already we know that 4 micro. What is the potential drop? This is minus 10 and this is minus 15. What is the drop? 5 only na? Because minus 10 minus 15, difference is how much? 5. So that's simply 5. So 5 into 4, 20. So 20 microcoulombs. 20 microcoulombs is passing through this one. As this is 20 microcoulombs, automatically through this also 20, because they are in a series, right? So this is how to do the When you are unable to identify which of them are in series, which of them are in parallel, you just go with this assumption. Okay, right. Now we will go for one more. We'll go for one more question. So here we will discuss some plates are given. Some plates are given. There are 4 plates. You can say this is A, B, C, like 4 parallel plates given. Some D. So this is A, B, C, D. And they have given Q1 to this one and Q2 to this one. So charges are Q1 and Q2. And this A is grounded. This is grounded. Now the question is, what will be the charge on this surface? Charge on this surface. The surface where we are earthed, grounded. So they are asking that. Simple thing. Here they have not given any charge. Here they have not given any charge. Only Q1 and Q2 given. And if it is not earthed, we have 4 plates like this: A, B, C, D. And while dealing with the Gauss law, I told you, if charges are given like this is 0, this is 0, the outermost surfaces must have the charges Q1 net charge upon 2. Means how much charge is there? 0 plus Q1 plus 0 plus Q2. This outermost surfaces must have Q1 upon Q2 by 2. And this side also Q1 plus Q2 upon 2. Means whenever this surface is this much, to get 0, what this side must be? Minus of this much. Minus of Q1 plus Q2 upon 2. When this is minus, opposite surface should have the facing surfaces should have opposite and equal. Means this is minus, means this is plus. Okay na? So this will be plus of Q1 plus Q2 upon 2. And you know already this is Q1, but our charge is Q1 plus Q2 by 2. So that this will be Q1 by 2 minus Q2 by 2. Again you will get, so that you will get the distributions. Okay na? So here what I told you, add all the charges and divide with 2, those are the charges on the outer surfaces. Now what we did, for this plate we just grounded. So ground will make, what is the use of the ground? Ground will make the potential of the surface to be 0, potential 0. But here what it will do, so when we grounded, this is some positive charge. So that what earth will do, it will send electrons, means negative charge it will send, so that it makes the charge on the surface 0. It makes the charge on the surface 0, means it will take the charge. So that finally what is the charge present on the surface? 0. What is the charge present on the surface? 0. It is the simple fundamental thing that earth will always tries to neutralize that surface. Means already some charge is present on this surface. So that earth what it will do? It will take the charge, so that neutral. So now what is the charge taken by the earth? Q1 plus Q2 by 2. This much charge it was taken. Okay na? Or you can say this much minus of charge send, so that this surface becomes neutral. So what is the question what is the answer for this question? Charge on the surface will be 0. Okay, right. We'll see for one more question. As we discussed some problems on dielectrics, where there are two plates and in between them some dielectric mediums are kept. Now how to do this type of question, where it is a dielectric medium K1 and it is a dielectric medium K2, and this one is K3. This is K3. See, what is the main thing here? Here we need to identify which of them are in series, which of them are in parallel. These are the plates, okay? Which of them are in series, which of them are in parallel. As we are going like this you can say series, this you can say series, and these two will be parallel. Now see, this K3 is whole thing. Now what I will do is, I will just cut half. So that the circuit will be like this. This is one plate, this is another plate, but this is K1, this is K3, and this is one more plate K2, and this is K3. Now I can say that these two are in series, these two are in series, the coming is parallel. Now the thing we need to know is the total distance is D and this is half distance. These are half distances, and the total plate area is A, so that this area is A by 2 and the down area is A by 2. So that areas are half, distance is half. Now coming to the first one, you know this you can draw like this, they are in series, so I am just drawing like this, okay na, and downward also I am drawing in a series way. Now tell me, what is the capacitance? You know the formula for a parallel plate capacitance is epsilon naught A upon D, but here it is not epsilon naught. When dielectric is kept K1 times, so this one will be K1 times epsilon naught. What is the area of this plate? Half only na. So area of the plate is half and distance is also half. It means half cancels, you will get simply K1 epsilon naught A by D. Then here also K3, this is K3 epsilon naught A by distance is D by 2. Now what is this one? Simple way, K2 epsilon naught A by 2 by D by 2. Now this one K3 epsilon naught A by 2 by D by 2. So we will get this one as simply, so 2 cancels, it is epsilon naught A by D, which is nothing but parallel plate capacitance, simply K1 times C. This is K3C, this is K2C, and this is K3C. When these two are in parallel series, what is the formula? Product by sum. Now you can say this combination I am writing up. So K1C and K3C, they are in parallel, so series, so that formula will be product by sum. So product is what? K1C into K3C by K1C plus K3C. Here C take common and cancel, so that you will get K1 K3 into C by K1 plus K3. This is the first capacitor, and the similar way you will get one more capacitor down, the same thing you will do, so that K2 K3 by K2 plus K3 into C. Now these two are in how? They are in parallel, so that add both of them, then effective in parallel, simply add. So when you add, you will get K1 K3 by K1 plus K3 is added to K2 K3 by K2 plus K3 whole into C. This is how to find out the effective capacitance. This is how to find out the effective capacitance for this circuit.